Exponential smoothing. It's a lot like best fit line, except for it's a curve. So let's go ahead and do this. We're going to pick a cell, any cell. We're going to go to data. Make sure you're in data analysis. Let's get this over here so you can see it. Data analysis. And please hold. Data analysis. And I want exponential smoothing. Click OK. Now the input range, I'm going to do Exxon first. We're going to highlight all the data. And it's going to use its perfect math skills to calculate what goes in where. And I'm just going to use the damping factor of 0.5. Remember, the higher the damping factor, the least amount of peaks and valleys. So 0.9, you're going to get almost a straight line. Okay, 0.1, you're going to get something that looks very similar to the original graph. So, and that's not what you want. So I'm going somewhere in the middle. And did I put labels in there? I can't remember. And the output range, I'm going to tell it where to put the output range. I'm going to put it right next to it, right there. Almost forgot the most important thing. Check the chart output. You want that graph, okay? And I got to apologize. There's too many data points here. We're probably going to get a real crappy looking graph because too many data points, not enough room on Excel. So it's going to squish them up, so it's probably going to come out to be pretty crappy. But let's take a look, and we'll probably get an error message. And we did. Just means we got too much data going on here for it to look. Yeah, that's what I thought. So now, this is not a very good graph whatsoever. So what happens is we got 248 data points on this tiny little thing. If you could stretch this out to, like the freeway, it would become much more easy to read. But what I'm going to do is I'm going to go ahead and delete most of the data for the next class, so it'll come out nice and neat. So give me a second. I'll show you how that's going to work. So I just deleted about 90% of the data. So again, starting from scratch. Exponential smoothing. Pick a cell, any cell. Go to Data tab. Go to Data Analysis. Exponential smoothing. Click OK. So my new data range is from C7 down to just C33. I'll just go ahead and type that in there up there. Beep, beep, beep. Okay. And my damping factor is 0.5. No labels. And I want my output range to be right next to the data, right there. And I want my box, my chart output clicked. Make sure that's clicked. Click OK. And again, there's not enough space between the things, but here's the graph. And that's a pretty good indicator, right? The orange is the forecasted, and it kind of follows the actual. So if I had to predict, I would say it's probably going to stay pretty much the same, a little bit higher than the last amount. So these are only, at $1, no, not even $1, like 58 cents apart from each other. So I would probably predict that the next price is probably going to be somewhere around $85.72 roughly again. So that's a prediction. Let's do that one here as well. Come here, you. So we're going to pick a cell, any cell, go to data analysis, exponential smoothing, and this is going to be, it's going to be the I. So if I replace that C with the I, that gives the computer the right column. Same thing, but now I want this one to be right next to the other one. Chart output is click, yes it is, click OK. And so here is our exponential smoothing for the microstuff. So you'll see at the tail end here, they're pretty bit different, right? The residual between is the residual is the word we use between a predicted value and the real value. And so this difference between the two is actually kind of high here. So I would probably predict that the actual value is going to jump back up a little bit. So I'm going to say it's probably going to be somewhere around the neighborhood of $110. How's that? And again, these are just close predictions. But that's how you do exponential smoothing. And I promise I'll try not to put too much data on there to get them crappy graphs. All right, but that's it. MGZ out.